Hello everyone, welcome back to our channel. So today we are going to solve the daily challenge from Leetcode. So let's see the question first, which is frequency of the most frequent element. Okay, this is a medium level question, and the question is the frequency of an element is the number of times it occurs in an array. मतलब कि कितने बार एक एलिमेंट ऑकर होता है एक array पे, and you are given an integer array nums and an integer k. Okay, and in one operation you can choose an index of nums and increment the element at the index by 1. Okay, and return the maximum possible frequency of an element after performing at most k operations. Okay, so to find the frequency, that how many कितना सारा एलिमेंट का फ्रीक्वेंसी अगर इधर के ऑपरेशन तक करेंगे तो कितना फ्रीक्वेंसी बढ़वा सकते हैं हम, मतलब किस चीज़ कौन सा एलिमेंट का फ्रीक्वेंसी मैक्सिमम हो सकता है. लाइक सपोज वी हैव 1 to 4 as a in arms as a input, and you can see that there have three elements and the k is 5. Okay, suppose we need to increment, we have seen that we need to increment the element by 1, so we cannot decrement. So suppose we have 4, and let us see that can we increase this part. If I we have 5 times, so if I add 2 more times, which is less than 5, then we can see that it will be 4, then our frequency will be increased. Okay, then after that we can also see that if the element is 1, we can increment 3 in 3 operations, where the at most operation is k times. Okay, which is less than the k times, so we can consider the frequency is for this example is 3, and that is the output. And example 2 is nums is given that 1 4 8 13. Okay, and the k is equal to 2. So you can see that let's see the most maximum element is 13, and if 8 can add increase by this, let's see, if I increment 8 by 5, let's see, 8 plus 5 will be what, simple with 12 and 13, it will be 13. So this will be it can be done by using the after the 5 operations. Okay, then let's check for 4. 4 plus 5 will be 9, so it cannot be reached the value 13. Okay, let's check for this is the maximum. Okay, uh, let's we are counting that this can be the most frequent value. Okay, so for that case we can check that 4 plus 5 will be 9, which can be done using 4 operation. 4 plus 4 will be 8. Okay, so then the frequency all will be 2, which we can already get from these two pair. And after that when we add 1, 1 plus 5 can be 6, which cannot be 8. Okay, after key operations, so we will not consider this. After that we can consider that 4 can be the maximum. Then what can be the answer? Then 1 can be, if 1 can be add up to increment up to 3 times, which will be less than k, then we can get that this will have 2 frequency. Okay, and the nums of the third example is the nums equal to 3 9 and 6 is given. Okay, suppose we have 3, and let's check, is there any kind of small operation, small numbers than 3? If yes, no, so the frequency is right now 1, because we count it as a 1. Then check for 9. We have 9, so we have the smaller element 3 and 6. So if we add 3 by 2, which will be 5, which will be less than 9, so it will not consider as a valid thing. And then we have the 6. 6 plus 2 will be 8, which is not considered as 9, so we cannot increment the the output. And if the maximum, we can consider that 6 can be the maximum frequent. Okay, then if I have taken 6, the less element than 6 is 3, and 3 plus 2 will be 5, which is not equal to 6. That's why the frequency will be same as 1. So that is why the output is 1. So now let's talk about the approach. How can we solve this question? We can solve this question by using, you know what, sliding window method, where we can short the value. Suppose these two are sorted already. Suppose we get the sorted value, which will be 3, 6 and 9, and then we'll check every boundary wise. Okay, like in this question, suppose this is sorted already. Suppose for the first case we'll check for these three things, for these two things, then we'll check for three things. We'll when we check that it will not considering as the valid thing, then we'll increase the left part, and we'll check this again, and after that we'll check this again. That is why that is how I'll find out the most probable answer, which will be the final answer. So for this part, as I told you earlier, we need to sort the nums array by using the sort function, and okay, perfect. Okay, so we can have a left equal to 0, right equal to 0. For the boundary cases I have told you, sum equal to 0. Also I will consider the num size, which will be the length of the array, will be n equal to nums dot size. And let's check, let's do one thing, use the for loop. That's why I will just remove the right part. We'll just write here right equal to 0, right always be less than equal to n, and right always be increment. Okay, so we need a sum, because we'll just calculate the boundary. When it will exceed, we'll just decrement the value to make the perfect boundary. Okay, like left and right must be the same. And also we forget to add the answer. Okay, answer equal to 0 at the initial time. Okay, okay, let's increment the sum equal to you know what, nums, the nums of right, and we'll check if they have the condition like it's exceeding, then we'll just do that, we'll just decrement the left nums of left. Okay, like this, like nums of right into what, into what, r minus l. R means the right, minus left, plus 1 is greater than, that means it's exceeding the sum plus k, that means exceeding the probable thing, probable values. Then what we can do, that nums sum will be decremented by the nums of left, because we are just lefting that part, that element, and the left will be increased to make the perfect boundary. And what if we get the boundary, and almost we have done, and after that we'll check every time that answer is maximum, like r minus l plus 1. So every time we'll check the boundary, we'll suppose this is the boundary, and this is if the greater than the answer, then we'll add it to our answer. Okay, we'll update the value of answer. And I hope we are done with this code, and let's check by using the run. And yeah, oh, this is not r, this is right, and this is left. I think no issues are there. And let's check for as well. Yeah, that's it, that is the accepted code. And let's find out the time complexity and the space complexity. For the sorting function, as we know, the time complexity will be O of n log n. So, and for this case we'll have you know what, n times here, and almost very less time will be here. So this is a sliding window method, so we can consider the whole block time complexity will be O of n, because we are using sliding window method. and for the sorting algorithm we have O of n log n. So we can consider the time complexity will be what? Time complexity will be O of n log n. Perfect. Yeah. So what will be the space complexity? Let's wait for a second. Okay, okay, what will be the space complexity? Is there any extra space we have taken? Yeah, we have taken only the constant spaces. This is just the variables, the integers, and we have not taken any kind of extra spaces in this case. So we can consider that the space complexity will be 1 in this case. So that is it in this code, and let us submit the code to check all the test cases in the problem. And let's check. Okay, I hope they will not have any kind of errors. Okay, so I think we are getting error because you can see the signed integer overflow. That means it's overflowing. So what can we do? That we can change all the integers by what? By long. Okay, to avoid this error. So we'll not change any, from here. We'll change. It will be replaced, and let's replace also this. Okay. I hope there will not have any kind of issues right now. Let's submit again, and let's hope for the best. And I hope yeah, that is the accepted code, and this is also a good code. It repeats 90% of the users question. You can consider almost this. It will be differ for many cases. uh, yeah, that is it. I have to tell you the time composition and the space complexity, and that is the medium level problem, and we have solved it, and this is my approach. That is it. Thank you all for watching this video. I'll see you in the next time.